Next up, we have problem 13 from chapter 16. It says, what are the three longest wavelengths for standing waves on a 240 centimeter long string that is fixed at both ends? So we just need to satisfy our fixed endpoint condition here. And so if we have a string here that is 240 centimeters long, then the first wave, the largest wave that can fit on this endpoint, or this string with fixed endpoints, is going to be half a cycle, or half a sine wave. That's node to node. And the full wave would be half a cycle longer than this. And so if the length of the string is equal to half the wavelength, the wavelength is going to be equal to twice the length of the string, which is 480 centimeters. The next one is going to be 2 half cycles, or a full wave. In this case, we've gone from our half cycle to our full cycle. This is the next largest wave in which we can satisfy this fixed endpoint with a node at either end. In this case, we have that just lambda is equal to the length of the string, or lambda is equal to 240 centimeters. And the third wave that can fit on the string is going to be a wave plus a half a cycle more, a full sine wave plus a half a cycle more, 1.5 wavelengths altogether, 3 half cycles. So we get that we get 3 halves of a lambda is equal to the length of the string, or lambda is going to be equal to 2/3 the length of the string, and 2/3 of 240 centimeters is 160 centimeters. So in part B of this problem, we're asked to solve for the second longest wavelength. Excuse me, it says if the frequency of the second longest wavelength is 50 hertz, what is the frequency of the third longest wavelength? So in this problem, we need to look at this from a frequency perspective, and we're told that the second longest wavelength oscillates or is driven by a frequency of 50 hertz. So as we just showed, the second longest wavelength is going to be the full cycle. The full lambda, 1 full lambda, is the length of the string, and this gives us a frequency of 50 hertz. And that 50 hertz is twice the frequency that we get for the first longest wavelength, or the fundamental. So this 50 hertz is equal to twice the fundamental frequency, which means that our fundamental frequency is equal to 25 hertz. And if we want to get 3 times as many cycles on the string and it's traveling at a constant speed, we want to be wiggling the string with 3 times the rate of the fundamental frequency. And that is going to give us the third largest wavelength, which is 1.5 cycles on the string. And that's going to be equal to 3 times the fundamental frequency, which we said was 25 hertz, which gives us 75 hertz as the oscillation frequency that produces a standing wave of this shape.